All right, so this is accumulation part one. We're talking about how, I think in accumulation is kind of important to understand that this is integration. So you might want to just write this here. I mean, that's what accumulation is. If something is accumulating, you're adding things up. If you think about an integral, it looks like an S. It looks like a sum symbol. And if you remember the trapezoid sum and Riemann sums and adding up rectangles and adding up bars and adding up circles recently to find volumes, we are adding things together, and that's going to find the total accumulation. I love to go back to the example of snow, and if you think of snow falling on the ground, and if you just add up all of those snowflakes, you'll get the total depth of the snow. That's accumulation. So accumulation is about summing things up, adding them up over a period of time. So this is an example you can do without calculus. A particle is moving constant velocity of 16 meters per second. So I do want to get a little bit of calculus-like notation in here. So v of t equals 16. We could just kind of say that. Find the position of the particle when t equals 4. So I just want to get the vocabulary down. I know you might have been able to do this in your head, but position is either s of t or x of t. We always say s of t, but it seems like the calculus exam has been saying x of t a lot lately. So I just don't want you to forget that it could be x of t, but I'm still going to stick with our tried and true s of t for position. And I actually know the position of the particle at 0, right? The particle started, here's what I kind of want to do. The particle started plus 13, right? So I'm going to actually say the position at 0, so I'm going to replace this with the position at 0 was 13. Okay. So, I mean, let's just think about this in our brains. Like, let's just not really do any calculus here for a second. Well, it's going 16 meters a second. We're going 4 seconds, so how far? I mean, this is the non-calculus way. Non-calculus. How far is the object going in 4 seconds?
64 meters.
Right. So I'm just going to say it went 64 meters because it was 4 seconds and it was 16 meters a second, so it went 64 meters. So it went 64 meters, I guess, up or to the right or whatever. It went positive 64 meters. It started where? It started at 13 meters. So if it started at 13 meters and went 64 meters, then we know it's 64 plus 13. That's what we need. And we have 77 meters. Okay? Now, you're going to think I'm crazy to use calculus on this, but I want you to see calculus on a simple thing so that you can understand it when it gets to something more complicated. Do you think that most things we study this year are going to be constant velocity? The answer is no. They're going to be a velocity with a bunch of variables in it. This is great. We're excited by this constant velocity, but it doesn't happen often. So we have to start with constant velocity, then you can understand how it makes sense in your brain, and then we can take it up a notch. So here's what I want you to understand. If we have velocity and we want to study position, right? If we have velocity and we want to study position, right? Position is what we want to figure out. How does velocity relate to position? Does velocity need to be integrated to get position or derived? Does it need to be anti-derived to get position or derived? Anti-derived, right? So if you were to integrate velocity, you would get position. But of course, we have a couple of things that are kind of weird about this. First of all, when are we integrating it from? Well, why don't we look at where the particle started and where the particle ended? So what I'm going to do is I'm going to focus on, it started at positive 13. Oh, that's a terrible color. It's ugly. Let's try this one. Okay. Oh, that's a little better. Burnt orange. Okay, so it started at 13. So I'm going to say at 0, it's at 13. And we want to know when t equals 4. So we want to know the position, the change in position from 0 to 4. So that's basically what we want to figure out. So what is that going to be? Well, how would we do that? Well, we would take the velocity function and integrate it, it's going to be 16t from 4 to 0. I mean, you're kind of thinking now that this is just what we did already. 16 times 4 minus 16 times 0, which is going to be 64 minus 0. So 64 is how much it changed. But the problem is that this, this hasn't really given us the whole picture. Because what happened is that it started at 13. So it's 13 plus whatever happens from 0 to 4. And here it's the same thing. It's 13 plus that. 13 plus that. And so then it's 13 plus this and 13 plus this. We had an extra 13. So that gives us 77. Oops. So that still gives us the same answer as we found the other way. Of course, you're finding that my calculus way is a lot more complicated, and that's how it's going to be. That's how it's going to be. All right? So hopefully we can make some connections here. So the first thing I want to show you is, this is option, let's just talk about these all as different options. So we have a couple different ways we could do this. Here's option 1, which is non-calculus. That option is going to go away 99% of the time. Okay? But that's option 1, non-calculus. We just do it in our heads. We know what's happening, and it makes sense. Here's option number 2. We don't have to do it this way. There might be some situations where we have to, but generally we have a lot of different options here. Instead of thinking of option 2, you could think of this as a differential equation. So what you could do is you could basically take this and you could integrate it. And then you'd have the integral of velocity of position, so you'd have 16t plus c. And then you would plug in, you'd plug in here, and you'd plug in, for this whole thing, you'd plug in the 13, and you'd find the c. You'd wind up with c equals 13, so your position is equal to 16t plus 13. And now you just want to know the position when t equals 4, so you go back here, and you plug in 4 to this equation, here and here, and you're good to go. And you can find out where it is. So 16 times 4 plus 13.